As a programmer, you really want to solve a problem once and reuse that solution in other places. For example, perhaps you define a function in one module that's really nice and useful, and you want to use that same function in other modules in your project. How can we do that? Well, in Python, we have the ability to import modules and functionality from modules into other modules in our projects. This type of functionality exists in other programming languages too, but some of the details are going to be different based on how those languages are set up. The same general ideas will apply though. So let's take a look at how importing works in Python. And if you want to join me in VS Code, that'd be great. I'm going to open up my File Explorer and notice that I've got a few directories set up. This is a Python workspace. I've got a lessons directory, and we can think about directories in Python as very similar to packages. And in a package, we're going to have many modules stored in it. I've got a lot of modules in here. Each module in Python is a .py file. Let's go ahead and set up a new module by setting up a new Python file. And I'm going to set up mine in my lessons package or directory. And we'll name this helpers.py. The purpose of this example file is going to be to demonstrate defining a module imported elsewhere. Okay. So what are we going to have in our module? Well, we want a really powerful function that we can reuse elsewhere. We're going to wave our hands at what that powerful function is. We're going to actually define a really simple function named powerful that you can imagine is indeed powerful, but is actually kind of silly. So let's go ahead and define a function named powerful. And this will be a function that just raises some x parameter to the power of n, which is another parameter, and will return a float. So the doc string here will be raised x to the power of n, and the implementation of this will just be simply return x raised to the power of n using the exponentiation operator. As you can already tell, this is, again, we're naming this thing powerful. It's really silly. This video is focused on how do we import this function elsewhere, because the same mechanics, no matter how actually useful your functions in a module are, will apply in the same way. Okay, so we've defined a function. How can we use this function in another module? Let's open up our File Explorer again and create another module. I'm going to once again create this module in my lessons directory. And I'm going to name this one imports.py. Right. And for the purposes of this video, I'm going to take my imports.py module tab and drag it to the left-hand side of my Visual Studio Code so that I've got these two programs or these two modules side by side. And in imports.py, example of importing in we'll make this, there are going to actually be a few examples of importing in Python. Okay. All right. So let's go ahead and set up this file to follow a Python best practice, which we'll learn a little bit more about in due time. And the best practice here is if we're creating a module that we intend to run as a program, we should probably have a main function associated with it. So I'm going to define my main function, and this main function is going to be the entry point of our program. So I'll make a comment to that. And what is this main function going to do? Well, we ultimately want it to call this powerful function over in helpers.py, but we don't know how to do that yet. So before we implement this main function, let's go ahead and finish up our idiom in Python for a module that contains a main function. We're going to test if the name variable of this module is equal to main. And if this feels like a magical incantation, you're right, it is. We'll learn about why this Python idiom exists and how it operates under the hood in just a moment. But the idea is when we run this module as a program, indeed, name will be assigned to the string main, and this main function will be called. So now we need to understand, how do we import this module helpers into this module imports? Well, we're going to need to learn some new Python syntax for that. And what we will establish is an import statement. So we're going to say from the lessons package, remember that's the directory that this particular module was defined in, we're going to import the module helpers. Okay. Now, where is this coming from? Let's just make a quick association here. Notice we have from lessons. So that's the package name that or the name of the package that we're importing from. We are importing a module named helpers, right? It turns out packages can be nested. So we could have had, say, lessons and then another directory or another subpackage and then another subpackage, in which case we would have said, lessons dot subpackage import module. But the key idea is we're importing from some package here, some module. And we'll see there are other ways that we can import even more specifically than this in just a moment, but this is sort of the best practice way of saying, okay, let's go evaluate this module and import what it contains. So after we've done this inside of our main function, we are now able to say print the result of calling powerful with say 2 to the 4th, right? But notice we can't call powerful directly. We see this red underlines. It's not defined. Well, when we import a module, all of the contents in that module's globals frame are going to be accessible via the module name itself, right? So we imported helpers. That establishes the name helpers in this imports.py module such that we can now say helpers dot and then reference the things that are globally defined in our helpers module. So helpers.powerful allows us to call this powerful function in the helpers module. So if I save this file, and we now have a simple running program that should demonstrate that this actually indeed works. So let's try this out. I'm going to try running the command Python, and I have on my machine Python 3.9 installed, which is a modern version of Python. So we're going to run using the -m modifier here, which says run a module as a program. All right, so we're going to reference this module here by its package name, lessons.imports. Right, so that's the package name followed by the module name. And what do you know? We get 16 printed out, which is 2 to the 4th. Right? And notice that this name variable must have been assigned the string main because main was actually called and this function was evaluated. Okay. How does this actually work under the hood? What's going on here? Well, it helps to think about what's going on in memory step by step to understand this importing system. So I'm going to jump over to a quick diagram of what's going on in memory, and I'm going to wave my hands a little bit at some of the details of specifically what's happening. But let's imagine that we had just started running this module here, lessons.imports, and we need to start understanding what's going on in memory. Well, I'm going to go ahead and set up my call stack for this particular frame and my globals frame for this particular file. So my call stack, let me go to a smaller pen here. Whoa. All right, so I have a call stack here. And my globals frame is specifically for the file imports.py, right? So lessons.imports is my module, right? So I'm going to go ahead and just make a note of that. We'll see why this is important in just a moment. So this is lessons.imports and the globals frame. Now, when we run this as a module, something special happens. Python behind the scenes sets up this special variable in our globals frame that is _name. And it is assigned the string _main. Right? And we'll see why this is important and useful in a second and when it wouldn't be main. But when you're working in Python, you know that any name that you see or identifier that's surrounded in double underscores has meaning that's very special and reserved for the Python language to use as it pleases and based on some conventions that it's specified. And here, when we ran this particular module, as a program, that's just what this was established to be, okay? So then we reach this import statement, and that's where the fun of this actually begins. What happens when we reach an import statement? Well, there's a very complex process ultimately going on, but we can think about this at a high level and appreciate that we're saying from some location, and that location is from the lessons package. What we're trying to do is import the helpers module. Right? And so Python has some rules for looking up, well, how do I find packages and modules? And that's a little bit beyond the scope of this video. What we can believe is that by saying from lessons the package, we have a directory named lessons in our project and a module named helpers in that package. We know that what we're going to be doing is evaluating this module. So at this point on line 4, what happens is Python pauses the program where we're at in imports.py and says, you know what? I've got to go fully evaluate helpers.py. I need to go run helpers.py as an imported module. Okay. So when we run or we evaluate a module as something that's being imported, there's slightly different behavior, but it's still very similar to what we're used to. Right? So let's go ahead and think about what happens here. Well, it turns out we're going to maintain a separate global space for this particular module. Right? So we're going to set up a lessons dot helpers space here. It's also going to have its own globals. And what's interesting about when you import a package is this special name variable will be a little bit different. So the name variable in this case would actually be the name of the module being imported. So it would be lessons.helpers. Okay. I'm just going to draw a line here to separate where we're thinking about. So this is the stack of lessons.helpers, and we're evaluating globals. And this will be my heap space over here. Okay. Great. So we've established this globals frame, and now let's keep processing helpers.py like we would any other way. So what do we see here? Well, we just see a singular function definition named powerful. Okay. So I'm going to set up a function definition for powerful. And we know that the name powerful is now bound to a function definition that is in helpers.py and is defined on lines 4 through 6 in that file. Okay. So we reach the end of this evaluation of this particular helpers file. And what happens next? Well, remember, we had just said we wanted to import what's in this module, what's in the helpers module, to our imports module, right? So what happens after we completed the evaluation of this particular file? Well, now the name helpers in the scope that we were working in and that we were importing in, so that was our global scope. So now helpers is going to be bound to whatever was defined in the globals frame after fully evaluating our imported module. Okay. So when we import a module, we fully evaluate it, and then whatever's remaining in globals is what will be bound to the name that we've imported, right? So helpers in this file now, following a dot, we can access anything that was defined in the globals of that module. Okay, so we'll come back to that and think a little bit more about it in just a second, but let's continue on. Okay, so we then see a definition for a main function. So there would be a function named main being defined in our imports file. And that would be the function defined in imports.py on lines, say, 7 to 9. And then we reach this if statement, and we test if the name is equal to main. Well, notice that, the current context we're working in is this globals frame here, right? And so sure enough, this name variable in this context is equal to main. So what we're going to do is go into the then block of this particular if statement and call the main function. So that would mean that we set up a frame for main, and our program continues on from here. And you can see that when we reach this print statement, when we reference helpers.powerful, what's actually going on is we're saying, okay, well, in the main frame, do we know of something named helpers? No. So we look in globals, and when we see helpers dot, we're following this arrow, right? We're following this reference to see, okay, well, what in helpers is named powerful? And that would be this function that's defined in helpers.py. And so notice what we've done is by importing a module, we can now access everything in its globals frame. So I'm not really worried about the continued evaluation of this main frame. It would be called, and then we would call powerful, and that would continue on as you would expect. I want to talk a little bit more about what's important here at when we're thinking about importing a module versus running a module as a program. So what if we actually added, say, a global variable to helpers.py? Something such as a constant like the answer, and I'll make a literary reference here to life, the universe, and everything is, say, 42, right? If we had added this to our globals frame in helpers.py, when we went to import from lessons import helpers, well, we know that the answer would have been a variable declared at the globals scope. So the answer would be in the helpers frame for globals, and it would be 42, right? Now, it's worth pointing out that we could also do something like print helpers.py was evaluated, okay? And let's try running this program one more time. Actually, before I do that, let's make reference to the answer from over in main and say something like print helpers. Let's use an F string here. The answer, and then we'll use a format string template to say the answer and helpers dot. So notice, again, we didn't import the name the answer, we imported helpers. And by saying helpers dot followed by this identifier, we're accessing that value stored in the globals frame of our helpers module. So now we can evaluate this program. So Python -m lessons.imports. And something interesting is happening. It says helpers.py was evaluated. So this print statement did execute, right? As soon as this import happened, Python needed to say, hey, wait, we need to go load this module and fully evaluate it. And we see that helpers.py was evaluated. We then see 16 because we went into the main function here, and we see the answer is 42. And notice we're able to access a variable that was defined at the global scope of this helpers module. So when a module evaluates, anything that is defined in the global scope is going to be accessible to where it's imported from. Now there's one other funny piece of business that we should talk about when it comes to the difference between running a module as a program and importing a module. So remember, right now we've been running imports.py as a program, and we've been importing helpers.py. What if we wanted to make it possible to run helpers.py? So let's say we have we'll follow our convention here and define another function main. So main, none. And what we'll do is just print, let's say, powerful of 2 to the 10th, so a much larger number. And print maybe another helpers.py run as a module, right? And we'll follow our convention here, which is if the name variable of this module is equal to main, we're going to call main. And I'm going to do something that is not idiomatic. We're going to add an else branch here, an else print helpers.py was imported. And I'm going to make this an f string. So I need to go back and add an f prefix here. Okay. Otherwise, if name is not equal to main, we'll print helpers.py was imported, and let's just see what's stored in this name variable, which was global. Okay. So I'm going to run this previously the same way we had before. Right? So we run this program, and notice that this print statement is evaluated. Python helpers.py was imported, and lessons.helpers must have been what was associated with the global name variable. Now, one other change occurred. I want to keep this diagram up to date. So if we were to imagine what happens when we import helpers, well, we establish this global variable, and then we have this main definition that exists over here in lesson.helpers. So we also have a main defined globally in this helpers.py file. This is the function in helpers.py. And I'm just going to scribble. We're not going to worry about the lines. We know that powerful and main are both functions defined in our helpers.py file. And the answer is a global variable that's assigned 42. Right? But notice that name is lessons.helpers. And we convinced ourselves that that must have been actually what name was assigned, because when we printed it out, that was in fact what was stored in it. Right? So there's something really fascinating going on here. When we import a module, this name variable is assigned what we call the fully qualified name, which is any package it's in, followed by a dot, and then the name of the module itself. And so what this gives us the ability to do is easily import just what's in globals without actually running this module as a program. But what happens when we try running python-m lessons.helpers? Notice that when we run just helpers.py directly, right? So there's a key difference here, and let's take a look at it. I'll make this just a little bit smaller so that we can fit everything on the screen here. So notice when I run python-m and then just this module, just the helpers module, we get the output 1024, and then helpers.py run as a module. That means this main function was evaluated. Why was it evaluated? Well, when we ran this module as a program, the name variable in Python was set to main. So the behavior is different when we run a module as a program, thanks to this special global variable that Python sets up, than when we actually imported this module into another module, in which case this name variable is set up to be the name of the module itself. And that allows us to have the best of both worlds. We can have a helpers.py file that both runs as a program standalone, but we can import the things that we define in it globally into other places without having its main function written. So typically we would not have an else branch here. And I might just make a note of that. This is not idiomatic. Or I should say, it is not idiomatic to have an else branch. And we'll just say, let's add a note here, idiom for importing for making a module able to run as a program or have its global definitions imported elsewhere. Okay. Now there's just a few other notes about importing that I want to mention. When we import, we tend to need to place these import statements at the top of the scope that we're importing. And so we're importing helpers globally here. It turns out it's pretty common that you want to alias what you're importing. So let's say helpers felt like a very long thing to have to write out. We could also say from lessons import helpers as HP. And what this does is it says, okay, rather than binding the name helpers in the globals frame to whatever the evaluation of this module is, we're going to bind the name HP. And that allows us to use HP dot the answer instead of, or HP dot powerful to access our functions defined in that other module. So if we wanted to imagine, well, what's happening when we do this in memory? Well, when we did that, we said HP is bound to what was in globals of loading that helpers module, okay? One of the cool things about importing modules in Python is that the first time you import something from a module, it fully evaluates. And then every time after that, Python remembers, oh, well, I've already evaluated that module before. Let's just assign a reference to what was left over in its globals frame. You can also directly import functions. I'm going to say that typically importing a module and then accessing the modules through that module, accessing the functions through that module's name. So helpers.powerful, hp.theanswer. That's what's considered best practice. But sometimes you just want to use a function directly, and you can do that as well. And so we can say from lessons.helpers import powerful. Import names defined globally specific. Right? So we can import the names defined globally in a module. We're going to import powerful from the helpers module. And this allows us to directly say print powerful of 2.4, right? So notice we didn't have to reference helpers.powerful. So what happens when we encounter a line like this? Well, what happens is in the scope that you imported, we would have a name powerful here. And it's going to be bound to whatever helpers.powerful was. So that's this function. And so notice it's going to be bound directly to that function definition. And so we're kind of foregoing the connection with to the lessons.helpers, and we would bind to that direction or that function directly. And that allows you to just access a function directly by its name. What we can also do, we can also, if you wanted to import multiple names that were in the globals of some module, we could also import the answer here, and we could also access it directly. So print the answer. And in doing so, when you import names from some other module into the current scope, again, the same idea would happen here. It's the same as saying, okay, well now in the globals of our imports file, we would have the answer and it would be bound to 42 in the globals frame of lessons.imports. They wouldn't be, 42 would still be what's in helpers over here, and we've effectively made a copy in our globals frame. So this is a quick introduction to the idea of importing. And in Python, and let's actually make one more note here. So alias a module imported name as another name. Right? And so the big idea is we can import some other module or definitions found in another module. What happens in Python when you do that is we go and we fully evaluate the other module with one key difference in how it gets evaluated versus when you run a module as a program. That special variable name is going to be set to the string, which is the name of the package, any packages it's in, followed by the module name, rather than _main. When you run a program as a module, the name variable will be _main. And so we go and we fully evaluate this other module, and whatever is left in its globals frame is what we're able to bind to, or is what gets bound to the name that we're assigning it. So when we import helpers, helpers is going to be bound to the globals frame such that we can say helpers.powerful to reference the powerful function, helpers.theanswer to reference a global variable. And if any other definitions that were contained in our globals frame, we could access in this way. It's very common that with longer module names, you really kind of want to have a shorthand to access it. So here we might, we can alias something we import. And all that's doing is setting up, just the same. It's a reference to that same globals frame. And we didn't have to, I should make it clear and obvious, we didn't have to do this import at the very top in order to alias it. You can do one or the either. Lastly, there are ways of importing names directly from one globals frame in a module into wherever you're importing your import statement is found in the module you're importing to. So that means that we could then directly call the powerful function or access this global variable, the answer, and we've effectively set up those names locally in this imports.py scope. As your programs grow in size, being able to import your functions from one place to another and make use of modules that are self-contained and have common functionality defined within them will help you better organize your programs and write more scalable, reusable code that you can make use of as you move forward in this course and in other projects.